Hello everybody, it's Mrs. Pound. We're still working on chapter 2.2 on soil. We have covered composition of the soil, we have covered soil profiles and different types of soil. And today we're going to take a look at soil and rock layers in section 224. So our objectives are to summarize how geologists apply the law of superposition, explain how the principle of cross-cutting relationships is applied to dating rock layers, and compare and contrast the three basic types of unconformities. So the first thing we're going to look at is the geologic column. This is the order of rock layers. So this is a lot like tree rings. A lot of times we use tree rings to date trees. We know that a new tree ring is laid or it forms during each growing season, and so we can count them and determine the relative age of the tree. It also tells us about what's going on for the tree during different periods of its life. Perhaps there was a drought, and so a ring is narrower than the other rings, or maybe there was a forest fire, so there's actually a char mark in there, or some kind of scar because something happened to the tree. So we can tell things about the history of the tree, and we can determine its age from the tree. And so scientists have applied that technique to the geologic column in order to determine the relative age of the rock in the earth. Now, a lot of these principles are used mostly by old earth scientists, not young earth scientists. Young earth scientists would say that some of these principles do apply. They would say, though, that compared to the old earth scientists would say that it takes much longer for these things to happen. The young earth scientists would say that it does not take as much time, okay, and would say that most of this happened during the flood. So the law of superposition states that the layers found lower in the sedimentary rock formation are older than layers found closer to the top of the formation. So here I have a geologic column. A is the youngest because it's on top. D is the oldest because it's on the bottom. So according to the law of superposition, the layer up here would be the youngest. The layer down here at the bottom of this rock would be the oldest. Now, the argument that young earth scientists would have would be that more than one layer can form at a time. Perhaps you have put some dirt or soil or mud or something, a mixture in some water and shaken it up, and notice that different things settle out at different times. So a younger scientist would argue that many of these layers might be about the same age. Yes, one got laid faster than the other because it settled out faster during the flood. Another thing that scientists can use to determine age of rock layers is a fault. A fault is a fracture in the Earth's crust along which rocks move. We know that if rock layers are split by a fault, that the fault happened after the rock layers were laid. So that is useful for determining when events happened in Earth's history. We can also have what are called intrusions. Intrusions are a large mass of igneous rock forced between or through layers of existing rock. And I know it's kind of hard to see in the background, but here, see these darker bands? Those are intrusions. Those are igneous intrusions that were put into this rock. And what happens is there are a couple of different types of intrusions. There are what are called dikes and sills. Dikes cut through the rock layer like here. So I have A, B, and C. The dike is cutting through these rock layers and forming a sill between A and B here. So like a windowsill. Think of a windowsill. And so we would know that the intrusions are younger than the rock layers because the rock layers had to be formed first. before the intrusions cut through them. And so that's actually the principle of cross-cutting relationships. There's also the principle of inclusions. These are rock fragments found in nearby rock layers, and they must be older than the rock layers that contain them. An example might be conglomerate rock. We know that and these are pretty large particles in this, we know that the particles, the pebbles that make up the conglomerate rock are older than the rock itself because those particles had to come from something else. And so those pebbles and the gravel and everything that's in the conglomerate is older than the rock that it's in. Then we have what are called unconformities. This is the eroded surface that lies between two groups of strata, and it is called an unconformity. And there are three general types we're going to talk about. You can see one kind of in the background here where we have rock strata layers going straight up here and then another layer on top of it tilted here. So we can see on these red lines, these are places where unconformities have occurred. We had an erosional surface. What happened was the land was lifted up, the rock could erode, and then at some point it sank back down and another layer was laid on top of it. So we have some nice horizontal ones here. We have an angular one here where there was actually some folding of the rock layer. It was tilted. And we even have one here where we have some igneous rock and we have an eroded area here. So let's take a look at what these can tell us. So these produce a gap in the geological record because layers of rock are missing because of erosion. Here we can see, we would expect with sedimentary layers that usually they're pretty flat in between. When they're laid down, they're very flat. And so here we can see this one is kind of wavy. So we know that this is an unconformity. And this type of unconformity is called a disconformity. Okay, this is a disconformity. It's in between two sedimentary rock layers. They occur when movements in the Earth's crust lift buried rock layers to the surface, exposing the layers to the effects of weathering and erosion. Now here, this is an angular unconformity because we have rock layers that are vertical, and then we have a tilted one that's almost horizontal. So rock layers have been lifted, and we call that angular because they're at an angle. And those eroded surface layers are eventually buried again under newly formed sedimentary layers. And here we have what's called a disconformity because we have granite on the bottom and sandstone at the top. When you have an igneous rock buried under more sedimentary rock after an unconformity takes place, after this weathering and erosion takes place, that is called a non-conformity. So just to review those types, we have the disconformity. This is actually the most difficult to identify because sometimes they're completely flat and straight, and so you just think that another layer got laid on top of it, and in fact there was a time gap where there was some weathering and erosion. Here you can see this is easier between this layer than it is between this layer. Angular unconformities, these are relatively easy to see because you have this angular rock and then you have a horizontal layer on top of it. And so you would know that this is older than this because of its position and also the fact that it was tilted and then this was laid down. And then a nonconformity right here where it looks like the igneous rock was eroded and then this layer was laid down. So that is your non-conformity. Now these can be really tricky. It's not always straightforward. They have to look for other clues as well. Perhaps in sandstone you can actually see ripples where the water rippled on top of the sandstone before it hardened. And so you can look for those and make sure that the ridges are standing up instead of upside down. If they're upside down, you know that something happened to that rock and it's older than you may think. Um, the disconformity, again, can be deceiving. So these are not, it helps us with clues. Also, younger scientists would point out that a lot of these catastrophes happened in very short periods of time, so they would disagree with the older scientists that would say that these things happened over longer periods of time. Other things that are used are fossils and radiometric dating, also to determine age by old Earth scientists. Younger scientists do have issues with some of these methods. That we will talk about later. And one of them that I'm going to point out now, because we are talking about the layers, is the fact that they have found tree fossils especially that cut up through multiple layers. So if those layers were laid over thousands of years, that tree would have rotted. There is no way that it would have left a fossil. And so one argument are these trees that go through multiple layers. All of those layers had to have been laid down very quickly at the same time for that tree to fossilize. So our objectives today were to summarize how geologists apply the law of superposition, explain the principle of cross-cutting relationships, how it is applied to dating rock layers, and compare and contrast the three basic types of unconformities. So don't forget your 5 questions.